using line equations. Example 1. Find the equation of the line L1 given 2 points on the line -6, -2 and 2, 2. So here we're given 2 points. Call the first one x1, y1, that's -6, -2, and the second one x2, y2, or 2, 2. We'll just keep those numbers available for use later. Using the formula for the equation of a line, we're told that y minus y1 is equal to m into x minus x1. Now, we have an x1 and a y1, but we don't have a value for m, the slope. So we have to look at the tables again for a formula for m. We're told that m is equal to y2 minus y1 over x2 minus x1. And all of these numbers we have, so we can now plug them in. So substituting for y2 and y1, for the 2 and the minus 2, we get y2 minus y1 is 2 minus minus 2. On the bottom, x2 minus x1, x2 minus x1 is 2 minus minus 6, 2 minus minus 6. So doing the arithmetic now, 2 minus minus 2 is 2 plus 2, which is 4. 2 minus minus 6 is 2 plus 6, which is 8. 4 over 8 is a half. So we found the slope of the line L1. We know it's equal to a half. So we can now progress. We know 2 points, but we'll just take one of them, -6 minus 2 for x1, y1, and the slope m of 0.5. Using the formula for the equation of a line, we get that y minus y1 is m into x minus x1. This is given to us. But now we have the values for y1, x1 and m, so we can substitute them in. Y plus 2, because y1 is minus 2, so y minus minus 2 will be y plus 2. M is 0.5, x minus x1, x1 is minus 6, so minus minus makes it a plus. So we get y plus 2 is 0.5 into x plus 6. And now we simply do the arithmetic. Y plus 2 is multiplying in 0.5x, half of 6 is 3. Taking the 2 to the other side, we get y is equal to 0.5x plus 3 minus 2. And 3 minus 2 is 1. So y is equal to 0.5x plus 1. So that's the equation now of the line. And if we were to draw that line, we would see that -6 minus 2 and 2, 2, x1, y1 and x2, y2 were on the line. We would also see that the slope for the 8 paces we moved from -6 to +2, we had to move 4 up from -2 to +2. So a 4 in 8 step, 4 over 8 for the rise over the length, 4 over 8, the slope is 0.5. And the equation is y is equal to 0.5x plus 1. Example 2. Verify whether or not the points -8, -3 and 7, 1 are on the line y equals 0.5x plus 1. So we may not have the line available to us to look at. We may have to do this through algebra. So we have to check whether this point -8, -3 is on the line. The approach we use is we check if the point satisfies the linear equation. So if we plug in the numbers into the equation, is it still an equation? So note, if a point satisfies the equation, then it's on the line. Otherwise, it's not. So how does this work? We'll test by entering the values. The function was y equals 0.5x plus 1, and the point we're interested in is this. Is -8, -3 on this line? So instead of using x and y, we'll use x1, y1. And we're checking is -8, -3 on the line. So we're saying y1 instead of y, x1 instead of x. Y1 is equal to 0.5, x1 plus 1. Is it? We're wondering, is it on the line? So we substitute the values in. Y1 turned out to be -3, x1 was -8. So is -3 equal to 0.5 times -8 plus 1? Well, let's see. -3 is -3. half of minus 8 is minus 4 plus 1. Minus 4 plus 1 is minus 3. So is minus 3 equal to minus 3? Looks like it is. We check, is minus 3 equal to minus 3? It is. Therefore, the point minus 8 minus 3 is on the line. And if we look at the graph here, we can see that minus 8 minus 3 is actually on the line. So it does satisfy the point. The point does satisfy, it is on the line, y equals 0.5x plus 1. Now we'll test with the point x1, y1 is 7, 1. Is 7, 1 on the line? So the same approach, we say y1 is 0.5 x1 plus 1 for the equation, and we plug in the values. Well, we have a question mark. Is 1 here equal to 0.5 times 7 plus 1? Well, half of 7 is 3.5. So is 1 equal to 3.5 plus 1? Well, 3.5 plus 1 is 4.5. Is 1 equal to 4.5? It doesn't appear so, so we check, and 1 is not equal to 4.5. Because it's not, the point 7, 1 is not on the line. And if we draw it, we can see here that we've got the line again, but point 7, 1 is out here, not on the line. So therefore, we can verify whether points are on or not on the line. Example 3. Find the equation of the line L2, given that it has a slope of minus 1 and contains the point 4, minus 2. So in this information you're told we know the m value and we know a point. So it's relatively straightforward now to get the equation. But we'll write down what we know. x1, y1 is 4, minus 2. We're just transferring the data. And m for slope is minus 1, because we're going to use this later to draw on it in our equation. Using the formula for the equation of a line from the tables, we're told y minus y1 is m into x minus x1. And we have our x1, we have our y1 here, and we have our m. So we should now be able to just substitute the values in. So y minus y1 was minus 2, so minus y1 would be minus minus 2, equals m is minus 1, x minus x1 is 4, so it's x minus 4. So writing it all out there, we can now simplify using arithmetic. Y minus minus 2 becomes y plus 2. Multiplying in, minus 1 times x is minus 1x. Minus by minus is plus, so that's a plus 4. And now we can simplify it again. Y plus 2 equals minus x rather than minus 1x plus 4. Taking the 2 to the other side, that will become a minus 2, so we get y is equal to minus x, and instead of 4, it's 4 minus 2, or 2. So the equation of the second line is y equals minus x plus 2. So that's the equation of L2. Example 4. Draw a graph of the line L2 given by the equation y is equal to minus x plus 2. So we're now going to draw that graph. To draw a graph, we find any 2 points on the line by selecting values for either x or y and determining the value of the other variable. So for example, you may choose to find the points where the line crosses the x-axis and the y-axis, or where x and y equal 0. That's another way of saying that. So when x is 0, we get that y is equal to minus x plus 2. That's the original formula. So substituting now for x equals 0, when x is 0, y would be not minus x, but minus 0 plus 2, or y would be 2. So when x is 0, y is 2, we're saying the point 0, 2 must be one of the points on this line here. Let's try when y is 0, and substituting for y, we say, well, if y is equal to minus x plus 2, and we're saying that y is 0, well then 0 must be minus x plus 2. So taking the x to the other side, we get x must be 2. So if x is 2 and y is 0 by choice, 2, 0 is on the line. So now we've got 2 points on the line. And we can draw it. But we didn't have to start with the intersections of the x and the y-axis. We could have taken any value at all and chosen the value for the other variable. So for example, using x is 3, we could find out what y would be. As always, the line is given by y is equal to minus x plus 2. So any value for x we can plug in and find the corresponding y value. So in this case, we're going to use x is 3. If x is 3, y is equal to not minus x, but minus 3 plus 2. Minus 3 plus 2 is minus 1. So when x is 3, y is minus 1. So 3 minus 1 must also be on the line. Now we don't need 3 points to draw a line, all we need is 2, but any two points regardless will do it for us. So here we are with the line drawn. It's the line of y equals minus x plus 2, and we can see that one of the points here was the point 0, 2. This is the intersection with the y-axis, and we simply made x equal 0. When x was 0, we found that y was 2. We got the other point by saying here's the intersection with the x-axis, and we said, well, let's just make it the x-axis, so the y equals 0. We said let y be 0, and we found that x was 2. But equally, we could have started and said let's pick the point x is 3, what's the y value? And we would have found the point 3 minus 1 was also on the line. So any 2 points anywhere along that line will allow us to draw the full line. So with any 2 points, it could have been minus 2, 4 or 4 minus 2, it really wouldn't matter. We'd still get the same line. We're now asked in example 4 to find the slope of the line L2 given by the equation. So if the line is y equals minus x plus 2, we can use calculus for this. So y is equal to minus x plus 2. Well then dy dx, to differentiate x we get 1, minus x we get minus 1. But the slope is dy dx. dy dx is just another term for m, the slope of the line. So we've actually found that m is minus 1. So we could have found the slope directly from this. So here's the line y equals minus x plus 2. And we can find the slope as well from the graph using any 2 points. So let's say we knew that the point minus 2, 4 and the point 4 minus 2 were both on the line. We didn't know the equation. We could still find the slope. And what we could do here is we could draw a line from minus 2, 4 down and across and say in moving from minus 2, 4 to 4 minus 2, I have to move 6 across from the minus 2 to the plus 4. But I'm also dropping 6 down as I go from 4 vertically to minus 2. So that drop is minus 6 as I go across 6. So minus 6 over 6, the vertical over the horizontal is minus 1. So the slope of that can be calculated visually, or it could have been calculated from calculus. The same answer, m turned out to be minus 1.